going to talk about improving cross-desktop standard. And so I'm Cedric, so I'm working on free software in Korea for Samsung. I am an enlightenment developer. Sorry for that. And I am going to talk about, give a little bit of context about enlightenment, and try by this presentation to share experience with people outside of the enlightenment community, so with the Gnome community this time, and share also what we are going to do with web and our system integration in the future. So the main reason is that we need to, there is a need to improve the communication across community. Because, for example, there was a free desktop kind of summit. It was basically Kali and Gnome, and they didn't bother inviting other desktops. So by coming by ourselves to show that we are willing to integrate and to work with others, maybe it will improve the situation. And, well, it's all about free software anyway, so we are sharing, yeah.
I was at the free desktop summit, and there were actually, most people were not KD or they were like rap.
Oh, really?
Cute or what that's called, and stuff like that. There were actually people from all the places, including Enlightenment.
There was no enlightenment. There was nobody from enlightenment, from LXDE, from
Yeah, I know. Not everybody showed up, but they were invited. It was really like Ryan really tried to get everybody on board. They were raising.
I have checked with everyone in the enlightenment community. Nobody did receive any invitation.
It's really not true. Like, we had all kinds of weird people there.
I don't know.
It was announced on desktop.org and everything, so.
I don't know. Just that never come there.
Really, I promise you. I was there too, and so it's like we.
I will believe you, but the thing is, communication didn't go well. So let's try to improve it. Let's talk about better communication, basically, which is the problem here. And that should be leading us to get better standard at the end. Right here, something is that at least this free desktop summit did have some feedback that was interesting. We have let's see to come out, but it was interesting. So what is enlightenment? Enlightenment is X window manager, kind of old stuff from 97. But it took us 10 years basically to do the next version last year. It's a component manager, it's a well and saver. In the meantime, we did write also our own toolkit, EFL, and our own terminal emulator. That is basically what it looks like, some old school stuff. So Enlightenment was Gnome Window Manager like more than 10 years ago. It was, there was an agreement between Carsten and Miguel Gazan at the time, and they did split away, and that's why Enlightenment took its own path and Gnome its other path. The discussion was at the time about integration of the window manager with the desktop, and it kind of now basically go where Carsten was saying at the time, which is, anyway. So, what is Enlightenment? Enlightenment is built on a few ideas. The main idea is that we don't believe that there will be a day with Linux desktop. That will not really be happening. We do think, and now it's kind of always it's true, but we did this moment with the idea was from 10 years ago, is that the future was in the embedded world. So we did build Enlightenment around the idea of embedded world and for also us developer. These tools were basically the same. We need a lot of options because for every device you have all of this kind of very little adjustment to do to be sure to have a nice experience. We also, because of the embedded world, we made enough effort to use as little CPU and memory as possible. And because every embedded device is different, we needed something that was easily themable and we can change very easily from one device to another. And adapt to, of course, every screen and input. So, what is the matter with embedded device? is something we have done with our work, is that we don't have much memory, we don't have much CPU, not much GPU also, and, well, the main point is we don't have much battery. That is the main issue. And in fact, when you optimize for battery, you optimize for all the other things at the same time. There is a direct link between our power consumption and the performance of the software itself. So memory and battery. Why does memory have a link to battery? Well, some hardware have the ability to shut down part of the memory that is not used. This means that when you are suspending, the only memory that will remain powered will be the memory that you are using. If you are using too much memory, you will be using a lot of energy when you are doing on suspend. When you are on suspend, and your device and mobile device is on suspend very, very often. So if you want to have a long life for your device, having not using too much memory during suspend is very important. Also, accessing memory costs much more energy than accessing the cache. So the bigger your applications, the more likely you are to go to memory to retrieve your information. So this is going to also use more energy. And also there is a little trend that is very important to know, is that memory bandwidths on embedded device don't increase that much. They are basically coming to a plateau. There is some kind of asymptote, and this means that we can't really count on the Moore's law to increase the performance on the memory bandwidth there. And finally, there is no swap on the device. So all of that together give you a huge pressure to not use memory too much. You need to be careful on what kind of memory you use and why you use it. Well, CPU is the most obvious of all of that. If you have a CPU, if you use a CPU, you obviously use battery to use it. That is kind of obvious. But it is not that obvious, because then you have multiple core. Is it better to have one core clocked at the maximum frequency to do something, or use multiple thread to finish early? And it's very dependent on the hardware you have, because some hardware can't really shut down the other core when the main one is running and something like that. So it's not obvious that going as fast as possible is always giving you the best performance on terms of battery. But doing as little as possible is always the best solution. So you need to be thinking carefully of what algorithm you are using to make it faster. Basically, to use less CPU. As for the GPU has some nasty problem, is that when you turn it on, it's basically another chip drawing energy. On this S9, when I turn on the GPU, I use 1 more watt. This means that I am losing like 45 minutes of battery, just by using the GPU. The GPU also, you are forced in OpenGL to always render full screen. That means that you need to refresh all the pixels. That is heavy and use a lot of energy. When you're doing software rendering, you can just update a small part of the screen, and that will be fine. That's why there is a huge difference between software rendering and OpenGL in terms of battery when you are doing something where just a cursor is blinking. That is something that I can maybe show. Here, you just see one terminal, and this small little blinking cursor in the corner will draw 1 watt if you are using OpenGL. If you are using software, you are not using this 1 watt because you don't need the GPU, and only this small cursor will be updated with the software, which is not the case with OpenGL. Oh, nice. So it's not always a good idea to turn on the GPU. It is when you need to update all the screen. When you're on a mobile device, when you have all this list moving in all directions and taking almost all the screen, using the GPU is absolutely needed. And it is using less energy than using the CPU to do it. But there is a trade-off. When you need to use it, for example, if you have a console, it's better to have software. And when you are doing something with list or whatever it is, you are better to use OpenGL that way. It's a case-by-case basis. This is true until you have partial update in OpenGL. That is something that is coming in the NVIDIA proprietary driver, and also will be mainstream with Wayland. I will talk about it a little bit later. Also, there is another thing that is very interesting is to not use the GPU at all and use layers, or video layers. Basically, this means that you don't need at all to use GPU to do the compositing. You are just relying on switching buffer, and that will be doing the trick. The thing is, the only problem is that the hardware layer are not always able to display every kind of content. And there are also some constraints on their number and depend on the architecture and the hardware you have, which is limiting it quite a lot. So it's a combination of all of that that make it efficient or not. And it's not obvious that you should, using OpenGL is not always a good idea. Well, the battery is the last problem, because the battery, they don't flow more slow. The battery, like, you get 10% per year, something like that. It doesn't increase at the same speed as more slow. So you don't really get more and more energy every year. So you can't really count on that to compensate for the problem. And also today, there was a study a few weeks ago about the efficiency of Core i7 and the Cortex A8. And basically, the instructional arm is using as much energy as they do for doing the same task on x86. There is no more win. It gives you the same energy consumption. This is important to remember, because that means that you have no special feature that make it lighter on the battery. It's only because the Cortex A8 is not able to do as much as a Core i7, basically. That is the only reason why it uses less battery. It do less. There is not much hope to have something breakthrough and have like 2 times more power and efficiency. The only way to get more efficiency is to shrink it more and more. That's the only way to get it. So battery will always be a limit, whatever you do. And that is true also on the laptop, as I was saying. So if you took on the laptop and you use Unity, basically versus Enlightenment, you are losing 1 hour. I have not tried with Gnome, so you will have to do it. And also when you use a web browser is kind of a really big hog of a battery. So you are losing hour. If you need to have some autonomy, just shut it down. That is something that will help you. And last thing by focusing on optimizing this kind of thing, we finally have an EFL environment that is faster than Android itself. And by being faster, we gain battery. So for example, if you do a device with Android, and you use the same hour as EFL, you will get 10% more battery. That means that if you have 10 hours of autonomy, you will get 11 hours. And if you have 20, I'll let you do the math, and so on. And this is true on a laptop too, because on this laptop, if I use Enlightenment instead of Unity, I am winning 1 hour of battery. This is huge, I mean. And so Enlightenment was designed for going beyond the desktop. This is something also the KDE guys are doing with Plasma Active right now. And the idea is that you have to have 1 profile per device, per screen. But you don't need to have 1 application per device. It's just a profile. This is also something that Ubuntu is doing and makes sense. Is that they are doing a design that makes them possible to have the same application, but with different front end, basically. And it really makes sense for the long term, because a mobile phone, if you accept the battery problem, it will have enough CPU power, and it already has more GPU power than my laptop. I mean, if I use that one, it's pushing more pixels per frame than my laptop. There is already a clear power into this device that is kind of able to replace the laptop in terms of power. It's more a problematic of connecting and how to use it, and the software issue. And to make things into perspective, right now, Android is kind of becoming a more and bigger problem. I mean, we have 1.5 billion devices this year that will be shipped with Android. That is more than the number of desktops in use today. There is 1 billion of desktops in use today. There will be more smartphones with Android. And there is nothing, no alternate solution at this point for it. And many countries, they start by using a phone, and they will not be using a laptop or a desktop anytime soon. but they are buying phone. Maybe they are buying huge phone like Galaxy Note, which are huge screen, but they are not going to buy a desktop. And this is no free software. And basically, it's a gate to the life. It's where you are using it all day long. As I say, they are as powerful as a laptop. So in a few years, they can really replace a laptop. It is just a matter of time. They have been replacing cameras. They have been replacing MP3 player. They can replace a laptop too. So when you are doing a development for an embedded device, do you really need to do specific software? For an application per device, for every screen variation, for every time you change your distance between your reading distance, every time you switch from touch to mouse or whatever, does it really need to be optimized for mobile? It doesn't really matter. It is just a matter of using different UIs that adapt to your computer. So you need to share to optimize it, so that's the easy part. As I say, you need to optimize it only for battery at the end. That means memory optimization first, that is kind of easy. You need to share content across applications. So instead of using buffer and copy, use a map file and share them across application. Finally, I agree that going to have a cache that will be a .desktop will be a maple. That is good news. We should be also going a little bit more further, like sharing glyphs and pixel data, because we are using the same theme, the same font, and that should be reducing the memory of the whole system too. There is a need to be able to throw this data and to link that with the kernel cache system so that we throw away when it's needed. And we should try to work on the toolkit level to share all this data across our application. As the screen variation, well, today most of the screen variation is handled by DPI. The problem is that DPI is not enough. There is also distance to screen reading, the distance to the screen, and also the personal sightseeing. I mean, not everyone has the same eyes, basically. So what we need is a scale factor for all the readable elements on the screen. That's what EFL does, is that it tells you basically for every font, for every icon, it will scale them if the scale factor is bigger, and it will scale them down if it's smaller. And that means that everything in the UI will be automatically adjusted itself to the resolution and the distance reading and to the sightseeing of the user, making things working on all kind of screen and device. This should be a cross-desktop standard, and we should be trying to push that into other toolkits. Right now, our idea is to push this kind of new feature more into Wayland, but I'm going to come back later on that. Input variation, it's the same thing. When you are doing touchscreen or a mouse, the only difference is the size of your finger. A mouse has a precision of 1 pixel. A finger, maybe 10, but that depends on your finger size. If you are a child, you have a small finger. If you have more adults, you have a bigger finger. So basically, finger size is also a metric to scale your button, all your clickable area on your UI. And that depends on your input device and your finger, because your input device can have a precision. It can be precise enough that it will be only the size of your finger. But sometimes it has the precision of 20 pixels. That means that all your area on your application should have at least 20 pixels to be able to click on it. But that is also something that should be part of the property on a window. And the last point, as I said at the beginning, when you are doing it to suspend, you need to really throw away all your cache and have just what is needed for the next frame. The reason is that when you are going to suspend, if you have less memory, you are going to save battery, and battery on suspend is the main use on a mobile device. When you are all your mobile device, when you turn off your screen, they go into suspend. So if you want to have battery life there, and you want to have them in your pocket and don't use too much battery, they need to use less memory. What we do on alignment and EFL is that we throttle themselves, they sleep. So every application will start to sleep if they get unified. This means that they will not wake up the CPU for the next 2 seconds, whatever happens. This is a way to force them to slow down on the number of updates they do. The problem is that you need to have a cooperation with the window manager and the component manager for that. So we need to be at the end also a standard between applications so that we can share this kind of information across. Because we need the window manager to wake up by sending a signal to the application so that it doesn't stop sleeping. It stops sleeping when it's unidentified. Also, another thing is that when you are doing animation where the application is not displayed in full resolution, you can drop frame. So you don't need to use all the CPU and GPU for something that is very small. You can drop like 20 or 30 frames. It will not be noticeable for the user. And that also saves battery. So that's the kind of thing that should be pushed more into toolkits and into also the window manager and the component manager. And in fact, it should be pushed into Wayland because there is no point at this stage to continue to improve X. Because X, first step, is impossible to secure. As soon as you start something in X, you need to forget about security. The only reason why it works on Linux is because we have a trusted link between the developer and the user. That means that we always trust the developer to do the good thing. But that is not going to be always true. So we need to move away from this assumption so that we can have third party that are apps, basically, that are not trusted. For that, we need to move to something else. That something else is Wayland. So X was designed for more than 20 years ago, and we have learned a lot in these 20 years. The composite manager was added later on, like less than 10 years ago. And with all this learning, we know how to do it better today. And clearly, Wayland is a very good design for composite manager. And it's needed because if we want to stay competitive in front of Android, there is no way around changing how we do the graphics stack. So right now, Wayland should be better than Android because Wayland is built with partial updates in its core and layer 2. So this means that every application that is full screen will not be composited. So it will not use the GPU, not use the battery. If you need to use the GPU because you need to composite things, it will use partial updates. So that means that we will be also more efficient on how much pixel we move around, which means that we will be, at the end, way better than Android. So this thing is really also needed to be competitive in terms of battery and life of the device. And of course, we are going to throw everything in the air, and it's going to support X. It still creates a lot more work on the composite manager. Now the composite manager needs to set up all the screen, all the different layers. It needs to do basically what X was doing. And it needs also to handle input and so on. So it put a lot of work on the composite manager. That means basically that Gnome will have more work with Wayland than before. And they need to do it because it's really needed for the community. And we have all agreed on this standard because the people doing it really know their jobs. They know how to make it secure, they know how to make it fast and efficient. And they know also how to handle input method. They know all the stack, they know it well. It's not people that will fall into easy misstep. And it's something we need to emphasize, but we should not even speak about mirror. I mean, as a community, the only way to go forward is to step up on Wayland and do something that is cross-tested here. If people have times, that's where they should put time today. Because as was stated yesterday, Wayland 1.2 is waiting on GNOME. So that is something we're really looking forward. The change, just sending a few stuff to the compositor, but the compositor wasn't in the middle of the flux of information. This means that basically if any client does any trick to the X server like redirect window or anything like that, can text, screenshot, fake input, whatever, and application does that, it will just make it impossible to secure things. That is the main reason. So that's why Wayland is in the middle and is taking care of routing inputs, on switching the buffer in an efficient way and so on. It's really changed the way things are done and for the better. The step needed to go to Wayland, that's basically what the Enlightenment team has been doing. We first did move to always compositing. So Enlightenment now is not able to run without compositor turned on. It's always there. In fact, we have been noticing that on all hardware we have Enlightenment with the compositor turned on, even the software is faster than X. So you can also, we're testing it on a 600 MHz Pentium 3, so there is no, the compositing is not something that's slowing you down. It is something if done right that makes your experience a better, and it's the way to go basically. The next step we did is to handle Wayland clients under it. So right now you can start Wayland application inside Enlightenment and that works. The next step now is to become a full Wayland compositor that is not yet upstream, but is working on. And that means that Wayland will not, Enlightenment will not use anymore X. It will directly communicate with KMS stereo and set up its own screen for itself. That is the last step, and hopefully it will come soon. Yeah, I'm very late. So we have also started to integrate with systemd. Basically, the reason is that we already have a script that was monitoring Enlightenment and restarting a few daemons. And all this thing was not really reliable. And I mean, it was some ptrace, it was some shortcut we were taking, because there was not really a portable way to do it. We still continue to support this way of doing things because we need to do it. But at least with systemd we have something that is way more reliable. And we have a lot more features that come for free. We have not to do anything to get watchdog, for example. And that is kind of cool. It also enabled to monitor much many more. I'm short. Okay. So we have not much time. So basically we are starting to move to integrate with systemd user session. It should be taking care of more things like starting application, like single instance application. We have yet to figure out the multi-instance scenario and also how toolkit pre-initialization can happen. There is one thing that we do in EFL is that we have a two-stage initialization in our toolkits. That means we can have a daemon running in the background that has EFL initialized. When the application needs to start, we just ask this daemon to fork and do the second stage initialization and run the application from there. This means that we have a startup time that is 20% faster than initialization speed. This is something that we are reluctant to give up on it. So we need to figure out how to do that correctly with systemd in the long run. But I'm not sure it's really a problem. So that's it. I'm sorry I'm making faster at the end because we are already too late. So is there any question?